Today we're talking about saw chain anatomy. In our example, we're using this oversized model to make it easier to see the chain components and to understand what it is we're talking about. We're going to talk about the drive links, the tie straps, the rivets, the cutters, and on the cutters, more specifically, the heel of the cutter, the toe of the cutter, the depth gauge, which is often referred to as rakers or drags, and it's here to control the amount of bite that the cutter takes. So the relationship between that working corner and the top of the depth gauge is really important. The gullet, the working corner, the side plate, and the top plate. You'll notice on our particular example, there's a line at an angle across the top plate of the cutter. This identifies two things. It identifies the angle at which to sharpen the cutter to, as well as identifying the end-of-life condition of the cutter. Not all of our chains have this, so you'll need to look at this and check it to make sure yours does. Now, as chains go, there are several different versions. This particular cutter shape is what we call a chisel. The chisel cutter is basically a 90 degree from the side plate to the top plate. We then have a semi-chisel, which means that there's a slight radius across this working corner. There's what we call a micro chisel. The micro chisel's radius is slightly smaller than the semi-chisel. And then we have a chamfer chisel, which means where the radius would be, there's a 45 degree angle. So let's talk some more about the different cutter types. The chisel chains are fast and efficient when cutting through wood. They're not quite so forgiving in dirty wood conditions because that working corner is extremely sharp and it will go dull quickly in dirty and sandy conditions. A semi-chisel and a micro chisel with their radiused edges spreads that working corner over a radius, which means they stay sharper a little bit longer in dirty and abrasive conditions, but they won't cut quite as fast or quite as efficient as a chisel chain. A chamfer chisel chain, again, is a little bit more forgiving in dirty conditions because it spreads that working corner over an entire edge, which means you have more surface area for that working corner. It's not as fast and it's not as efficient, but it will stay sharper just a little bit longer. All of those different styles of cutters come in different chain types. All of our drive links and our chains are stamped with a number. This number identifies the pitch and gauge of a particular chain. The pitch and gauge of a chain is critically important to maximizing the performance of a chainsaw. Let's talk about pitch for just one second. Pitch is identified as any 3 rivets from the center line of those rivets divided by 2. In this particular example, you'll notice this oversized drive link has 72 on it. That means that the pitch of this particular chain would be a 3/8 standard pitch. The gauge of the chain must match the gauge of the bar, and the pitch of that chain must also match the nose components on that bar as well as the drive sprocket on the saw. I hope this information on saw chain anatomy has proven helpful and assists you in choosing the proper chain type for your specific application and needs. And if you have any further questions or comments or needs more specific information, please go to OregonProducts.com.